Okay, so in the last part, we have discussed about the basic definitions and the about the forces and some introduction about the physical world, science, and physics. Okay, so let us continue our discussion on the basic forces. In the last part only, we have studied that there are four basic forces: the gravitational force, weak nuclear force, electromagnetic force, and the strong nuclear force. Now, these are the basic forces in nature. As you already studied, okay, so they are somewhat related to the basic properties of material, like the mass is related to gravitational force. Okay, if object has mass, definitely it should experience the gravitational force, and if object has charge, then it should it should experience the electrostatic force like this. The nucleons present in the nucleus, they experience the strong nuclear force. So these are the four basic forces in nature. Now in today's class, okay, so we are going to discuss about unification of forces. What is meant by unification of forces? Okay, some of the scientists, physicists, they argue that these forces, these four forces come from a single force. See, one force, it governs the entire universe. Therefore, they want to unify these different forces into a single force. In the last decades, there are many observations, there are many experiments. Okay, they try to connect this fundamental force into a single force. Now, the first attempt is made by Sir Isaac Newton. So, the gravitational force, the basic concept of gravitational force, it is given by Sir Isaac Newton only. So, before Isaac Newton, okay, so, or during his period, he has introduced the gravitational force. And the gravitational force, what is the beauty of this gravitational force? We thought that the falling of the apple and the revolution of the rotation of earth around the sun or moon around the earth, they are different phenomena. The falling of apple on the ground, the falling of freely object on the ground, it is a celestial phenomena corresponding to earth. Okay, so something which take place on the earth, we call it as the celestial phenomena. And the movement of planets around the sun is an terrestrial mechanism. So this is an celestial mechanics and it is an terrestrial mechanics. So two different mechanics here. The mechanics, the moving of object, whatever may be. Okay, so we study on the earth, we call it as the celestial mechanics, and on the space, the movement of the sun, the spinning of, okay, so the planets, the rotation of planets in the solar system, they are considered to be an terrestrial mechanics. Newton introduced the gravitational force. Newton introduced a gravitational law which says that the force which is responsible for falling of apple and the force which is responsible for the rotation of planets around the sun is same, and he called that force as the gravitational force. Therefore, this gravitational force has unified the celestial mechanism as well as the terrestrial mechanism. So this is one unification which is done during 1687. Then before 18th century, we assume that electric force is different, magnetic force is different. Okay, the charge experience electrostatic force and the magnets experience the magnetic force. But the Hans Christian Ørsted, okay, he is the first scientist, he said that no, and the experiment conducted by Michael Faraday, okay, so their experiments, their observation shows that this electric phenomena and magnetic phenomena are interconnected. Who is responsible for electric force? Okay, electric field, the charge is responsible for the electric field. And the same charge, when it is in motion, it produces the magnetic field. Are you getting me? So therefore, source is charge. The charge at rest, it leads to electrostatic field. The charge in motion, it leads to magnetic field. So the basic domain is same. The basic domain is charge. Therefore, the Oersted experiment and the Faraday's experiment, their observation shows that electric and magnetic phenomena are inseparable aspects of a unified domain. Which is the domain here? Electromagnetism. Next comes in a picture. In 1873, James Clerk Maxwell, he has given a four equations, very beautiful equations, are called Maxwell's equation. See, according to Maxwell, the electric and magnetic phenomena, they are interconnected. Electric field gives rise to magnetic field in some cases, and in some cases, magnetic field gives rise to electric field. Okay, so therefore they are interconnected. Plus, now Maxwell says that he connect electricity and magnetism with optics. What is optics? The study of light. Okay, the physical nature, its behavior, its propagation of light is studied in a single topic by the name called optics. Now Maxwell says that this electricity and magnetism and optics are interconnected. So he is unified electricity and magnetism and optics. How is unified? Very simple. Optics means what? The branch which deals with light, and Maxwell says that light itself is a electromagnetic wave. Light is nothing but an electromagnetic wave. Light itself contains two fields, electric field and magnetic field. Therefore, light itself is an electromagnetic wave. Light itself contains electric field and magnetic field. Therefore, electricity, magnetism, and light are interconnected. So, James Clerk Maxwell in 1873, he unified electricity, magnetism, and optics. Then comes 1979. Again, a very revolutionary theory is given by Sheldon Glashow, Abdus Salam, and Steven Weinberg in 1971. They show that, okay, so based on the theory, the beautiful theory, they show that weak nuclear force and electromagnetic force. Now see, these two are very different. Weak nuclear force is one type of force which act, okay, so between when during radioactivity takes place, the nucleons and the alpha particles, they experience some amount of force. Now that force is nothing but weak nuclear force, and the force between the electric charges in rest or in motion, now that particular force we call it as electromagnetic force. We assume that they are having the different domains. Weak nuclear force is different from the electromagnetic force. But the Glashow, Abdus Salam, and Weinberg, they say that this weak nuclear force and electromagnetic force are the different aspects of a same force. Okay, their origins are same, and it is nothing but electro-weak force. Which force it is? The electro-weak force. Now, electro-weak force, it gives rise to electromagnetic force in some cases, and it gives rise to weak nuclear force in one cases. So, these three persons unified weak nuclear force and electromagnetic force, and combinedly it is called as weak nuclear force. Okay, now definitely it is somewhat a major theory given during the 1979. It is based on the purely, it is an empirical, it is based on the theories. They have given some theories. Okay, so bosons, they have introduced the particles called the Higgs bosons. It is a different theory. It is, therefore it requires certain verification, and it is verified by in 1984 this Carlo Rubbia and Simon van der Meer in 1984. They verified experimentally the predictions of the theory of electro-weak force. Therefore, it is an acceptable. Okay, so therefore, see, these are the major events here, achievements in case of unification. Albert Einstein also tried. See, now also, okay, there are different scientists in the world. They believe that all force come from some single force. Okay, now that theory is called the unification theory. Okay, so first attempt it is made by and the Albert Einstein in the last period of his life. He tried to unify all these forces into a single force, but he failed. Okay, unfortunately, he couldn't unify this all the forces into a single forces. But still, we believe that they all come from a single force. Still, the observations, the experiments, and theories are going on in different parts of the world just to unify the four forces into a single force. Okay, now this is about the forces and the unification of forces. Now next move on to our next part, that is the physical laws. See what is meant by physical laws. We have the different phenomena in nature. Rainfall, okay, sunrise and sunset, the twinkling of stars. So we have the different phenomena. Okay, if you look at the sign, you can see there the cloud is there, the formation of rainbow. Now these are the natural phenomena. Okay, and these phenomena are not a accidental phenomenon. Remember one thing that okay, the each and everything in the nature it obeys certain law. Okay, planets are revolving around the sun. It is not an accidental behavior. Okay, it is a systematic behavior. Earth takes 365 days to rotate around the sun. It is a very systematic. Okay, it doesn't delay. Okay, it doesn't comes early. It takes 365 days only. So if the systematic, if the phenomena is systematic, then it should obey certain laws, and that laws we call it as the physical laws. Each and every phenomena in the nature it obey the physical laws. What is physical laws? If I take some typical definition, physical laws are typically conclusions based on related scientific experiment and observations over many years, and which have become accepted universally within scientific community. We have observed certain phenomena. We have made a systematic observations. We verified that observations data by using the scientific experiments, and it is not a period of 1 or 2 years. We have taken so many years, so many scientists are involved in this, and finally one person has given a law, and that law is accepted by the entire scientific community. Now they are called physical laws. Okay, if I take an example, the simplest one is that is, you know that the planets, the moon, the satellites, okay, so the planets around they revolve around the sun, the moon and satellites they revolve around the earth. Now this is an observation. Now this is an okay. Now this is the first. It's a very okay. So in ancient period only we know about these planets. Okay, in the different literatures, in different philosophies. Okay, so they know about the planets. Okay, so someone says that 7 planets are there. Some philosophy says that there is 9 planets are there. So during the scientific approach, okay, before scientific approach only, the peoples, the philosophers, they know about, okay, now these planets and all. No, it is on the very simple. It is based on the systematic observation. Okay, they are systematically observed and they have written in their literature. Okay, so when scientists and physicists comes into the picture, they make the systematic observations. They make a data observations data. Okay, they start calculating the physical quantities, and finally they relate this observations and quantity in a mathematical language. See, physics is a subject, and what is the language of physics? It is mathematics. Okay, whatever may be, we finally introduce the laws. We write the laws in terms of mathematics. So maths is the language of physics. Okay, finally we are going to write that observations and data in a single sentence by using the mathematics, and finally we call it as the physical laws. For an example, this one, the falling of apple and the rotation of planets around the sun. Who is responsible? Very simple, the gravity is responsible. Then the Newtons comes into this picture. Okay, so he says that yes, the gravitational force is responsible, and he has given a law. Now that law is called Newton's law of gravitation, that says that the force between the two objects, gravitational force, okay, if gravitational force acts on the body, then how many minimum bodies are required? Minimum two bodies are required. Minimum two bodies are required. Those should have certain finite amount of mass. And Newton says that the force of gravitation between two objects is directly proportional to product of their masses and inversely proportional to square of distance between them. More is the mass, more will be the gravitational force. Larger is the distance, lesser will be the gravitational force. He has given a law, and finally he has written that law in terms of a mathematical form, that is F is equal to G into M1 into M2 divided by T square. And finally he has written in terms of some mathematical statement. Finally we call that law as Newton's law of gravitation. So Newton's law of gravitation is nothing but a best example for physical laws. So we have the various laws like Coulomb's laws. Force between the 2-point charges is directly proportional to product of their charges and inversely proportional to square of distance between them. The Lenz's law. Okay, so we have the various types. The Faraday's law, the rate of change of magnetic flux induced is directly the magnitude of induced EMF is directly proportional to rate of change of magnetic flux. You can have the various laws in science, and that laws are, we call it as the physical laws. Are you getting me? Okay. Now we have so we have the quantities. Physics means what? Physics we deals with the quantity, and that quantities are called physical quantities. Okay, so we have the two type of quantities. One is physical quantity, and second is the non-physical quantity. What is physical quantity? The quantities which can be measurable. The quantities which can be measurable. For an example, height. Height, definitely it is measurable. Weight. Okay, if I ask something about your weight, definitely you can give some answer. Okay, so that weight is a measurable quantity, physical quantity. The distance, okay, no, these are physical, and there are certain non-physical quantities also. For an example, love. Okay, love towards a certain person. Love is a quantity, but it is not a physical quantity. Okay, you cannot measure the love, okay, by using certain units. You can't say that, okay, I have a love towards you of 1 kg, 2 kg, and 3 kg. That is meaningless. Okay, sadness. See, I am very sad today. Okay, you cannot measure this sadness here. Okay, you can't say that I have 1 liter of sadness. Okay, today I am having the sadness. Okay, of 10 liters, like this. There is no unit, there is no quantity to express the sadness. So they are called non-physical quantities. And our discussion is about the physical quantity. In physics, we discuss about the physical quantities. And again, in physical quantities, see, there are some physical quantities which depend on time, and there are certain physical quantity which doesn't depend on time. Okay, so when you go into the deep into this physics, you will get large number of physical quantities: mass, length, time, force, momentum, angular momentum. These are all measurable quantities, and we call that quantities as physical quantities. And there are certain physical quantities which remain constant. Okay, which doesn't changes with time, and there are certain physical quantities which changes with time. Okay, in one time you have some physical quantities there, but now that quantity changes in other cases. Okay, the quantities which are constant in time, now these are the most important one. The phenomena, the laws to understand the particular phenomena or the particular section of the topic. If that quantity remains constant, then what we are going to do is we are framing our entire theory on that physical quantity. Okay, so now that quantities are very important. Now that quantities we call as conserved quantities. Okay, the physical quantities which remain constant with the time, they are called conserved quantity. Okay, the physical quantities that remain unchanged in a process are called conserved quantity. So example is, if I take an example of this, see, there are various examples are there. Okay, so let me, for the sake of discussion, let me take some of the examples on conserve. The most important conservation quantity. The number one is law of conservation of energy, the basic conservation law in nature. Law of conservation of energy. What this law of conservation of energy says that energy can neither be created nor be destroyed. You can't create a small amount of energy and you can't destroy a very small amount of. You can't create the energy. Okay, the human beings are incapable of producing any type of energy, and we are also incapable of destroy any amount of energy. Now that is the conservation of energy. Energy can neither be created nor be destroyed. What we can do? We can only convert one form of energy to the another form. Okay, so we can convert one form of energy to another form. Again, there are two type of forces are there. Okay, based on that energy, we have the conservative force and there are non-conservative force. Okay, in some cases, one form get to another form. That means, for an example, if you take this example, some object is there, football is there, it is falling towards the earth. Initially, the football is at rest. That means the entire energy is the potential energy. When you just drop that particular football, now it starts moving towards the earth. Now what happens here? When it moves towards the earth, slowly its kinetic energy goes on, increases. Its velocity is increasing, but its potential energy is decreasing. Initially, when football is at rest, okay, when it is at rest at a particular height, the entire energy is potential energy, and your kinetic energy is zero. Okay, so when you leave this football, now slowly when it falls towards the earth, its kinetic energy goes on, increases, but the potential energy goes on, decreases, so that the total energy remains same. Definitely, we are going to prove in the next consecutive lectures, in next, okay, so 2 or 3 topics, definitely, we are going to prove this law of conservation of energy. Okay, here the kinetic energies get converted to potential energy, and in some cases, the potential energies get converted to kinetic energy. Now, that is called law of conservation of energy. Again, there may be 2 possibilities. Sometimes what happens now, here, now this is a conservative force example. Okay, who is responsible for the falling of football? Now that is a gravitational force, and gravitational force is an example for conservative force, where the mechanical get converted to kinetic and kinetic get converted to, okay, so the potential get converted to kinetic and kinetic get converted to potential. Now they are called conservative force. In some cases, what happens? See, in some cases, the energy, definitely, now these are called mechanical energy. The potential energy and kinetic energy are called mechanical energy. In case of free fall of a football, the kinetic get converted to potential, potential get converted to kinetic. Still the total energy is the mechanical energy only. But in some cases, what happens? Now see, so when you keep the football, okay, so when let me assume that you strike on the wall. Okay, when it strike on the wall, what happens? You can see the sound also. So during this case, see, there is, okay, when you kick the ball, that kinetic energy, when it strike on the, okay, so wall, see, some of the kinetic energies get converted to sound energy. Okay, the total energy remains the same, but here the kinetic energy has been converted to the sound energy. So it converted from mechanical energy to some other form of energy, but the total energy remains the same. In this case, now such kind of force we call it as the non-conservative frictional force. Okay, when you move one object on the other object, now definitely for the movement, okay, you push or you apply certain potential energy, that converted to kinetic energy. But in same cases, what happens when you push an object on one object on the other object, heat energy is produced. Heat energy is an non-mechanical energy. Therefore, your some part of kinetic energies get converted to heat energy. Why this heat energy has been liberated? Definitely it is due to an friction. Okay, some friction is there. Due to that friction, you are getting an heat energy. Okay, so therefore the friction is a non-conservative force. Similarly, you have the law of conservation of mass. Okay, first is the law of conservation of energy. Second is the law of conservation of mass, which says that in a closed system, all the transfer of matter and the mass of the system must remain constant over the time. Okay, the total mass of the system, it remains constant. Again, you can't create mass or you cannot destroy mass. It remains same. Okay, so you can take any chemical reactions. Okay, for an example, now some chemical reaction is there. Now CaCl2 and Na2SO4. Now these are different solutions. If you look at the total mass here, the total mass is what? 300 300.23 gram. Now that remains. Before reaction, it is 300.23. Now they are doing the certain chemical reactions here. So they are mixing the one solution with the other solution. So you can see here. Now there's some chemical reaction has been take place. It becomes a CaSO4 in one cases and NaCl, the sodium chloride solution, in the other cases. Okay, so CaSO4, you are getting a white precipitate in sodium chloride solution. Now there is a rearrangement of the elements take place, but if you look at the mass here, or the mass after the reaction, again it is 300.23 gram only. So the mass before the reaction is same as that of mass after the reaction. So the mass remains constant. That is called law of conservation of mass. But when Einstein comes into this picture, okay, in case of quantum theory, in case of microscopic domains, okay, in case of microscopic domains, like if you take the topic of atomic physics, if you take the topic of nuclear physics, now what happens here? Okay, so when you combine one protons with the other protons, you will get a new proton. Okay, for an example, you will get a new element. Okay, if you take 1H1 plus 1H1, that is, you are combining one hydrogen with another hydrogen, you will get the deuterium. Okay, deuterium nucleus, 1s2 deuterium nucleus. Now what happens here is, in case of nuclear reactions, again, as I said, that the law of conservation of mass, the mass of the product should be same as that of mass of the reactions. But in some cases, in case of nuclear reactions, what happens is the mass get, okay, there is a missing mass. There is a missing mass. There is a defect of mass. Your mass of the product is same as, it is not same as that of the mass of the reaction. There is some missing mass, and Einstein says that now that missing mass appears in the form of energy. That is called E is equal to mc square. E is equal to mc square. What is m? M is nothing but the mass defect in the particular reaction that appears in the form of energy. And in some cases, the energies get converted to mass, pair production. Okay, when a gamma radiations are incident on a light, after that you will get an electron and the antimatter of electron, that is called positron. So you are producing the new elements, electrons and positron, from an energy, from the gamma ray. So in nuclear reaction, now what happens is the energy and mass are interconnected. Einstein says that now this is a law of conservation of energy and mass. Okay, now he says that now in case of nuclear reactions, there may be annihilation of mass. You can destroy the mass, and that mass appears in the form of energy, and energy can be converted to mass. Okay, so now he has so the Einstein interconnected energy and mass. But anyhow, the total, okay, in an isolated system, your energy and mass again remain conserved. There may be transfer of mass to energy or energy to mass. Okay, so these are called conservation laws. If you take the other example for the conservation laws, the conservation of momentum. Momentum is nothing but a product of mass and velocity. Again, it says that, okay, so the momentum remains constant. Okay, when there is a collision of the object, one object collide on the other object, there may be transfer of velocity, the transfer of kinetic energy, but the total momentum remains constant. Okay, now these are the general laws here. Okay, now the best example of conservation of momentum is launching of the rocket. Before launch, the total momentum of the rocket and its fuel is 0. Okay, so rocket is initially at rest, therefore its momentum. What is momentum? Product of mass and velocity. So rocket has got certain mass, but initially it is at rest, therefore its velocity is 0, therefore its momentum is also 0. And fuel is present in the rocket, again it is in rest, therefore its moment is also 0. During launch, what happens when the rocket moves? Why this rocket moves? The downward momentum of the expanding exhaust gas just equals in magnitude the upward momentum of the rising rocket. Now what happens? So when this exhaust gas, they apply certain momentum on the earth. Okay, so to conservation of momentum says that the momentum before collision should be same as that of momentum after collision. What is the momentum before collision? It should be zero. And what is the momentum after collision? It is also zero. Okay, so therefore when this when these exhaust gases, they apply certain momentum on the earth, that momentum should be same as that of momentum gained by the rocket in the upward direction. So the momentum of the rocket is in upward direction, the momentum of the exhaust gas in the downward direction. They should be equal in magnitude, so that the total momentum again it becomes zero. Okay, so therefore we can apply the law of conservation in different cases to study the different phenomena. Okay, anything will take place in the nature, it should obey one or the other law of conservation laws only. Okay, so first law of thermodynamics, it should obey the law of conservation of energy. So these are the basic laws here. Okay, so the total momentum of the system remains constant. In this case, definitely it is zero value. One more is there. One more, the basic law of conservation of momentum. And the next external force acting on the system is zero. Its total angular momentum is conserved and hence does not change. Okay, so we will going to study this particular example in case of rotational motions. You can see here. Okay, so someone gymnastic artist is doing certain gymnastic work here. So you have the word called dl. L is called the angular momentum, that is the product of moment of inertia and the angular velocity. You can see here the moment of inertia, it depends on mass of the body, and it also depends on the distance of axis of rotation. In the first case, you can see that her answer so very wide, so that the R is more, therefore I is more. But there is no external torque, there is no external force here, therefore L should remain constant. In the first case, I is more. In the second case, C, she is moving like this. Okay, so as automatically decreases particular axis of rotation, so I has been decreased. Okay, in the first case, I is more, in the second case, I is less. If I is more, then W will be small. The omega is nothing but angular velocity should be small. In the second case, your R is small, therefore your omega dash should be large. Okay, so definitely somewhat it is a complicated quantity. You will going to study in the rotational motion, but anyhow, see why this the speed of the particular so the gymnastic artist changes. Definitely it is due to the conservation of angular momentum. Okay, when you spread your hands in very wide and if you rotate, your angular velocity is small. But if your position is like this, you have decreased the moment of inertia, automatically your angular velocity increases. Okay, so this is in case of if you want to go, if you want to revolve in a very slow manner, then you have to expand your hands like this. If you want to go in a very fast manner, then your position should be like this. Why this take place? It is due to an law of conservation of angular momentum. Okay, again there are various laws are there, like the law of conservation of charge says that the total amount of electric charge in a system doesn't change with time. Okay, so there are various laws are there. Law of conservation of spin, law of conservation of parity. Okay, so there are large number of law of conservation. So in any phenomena, so the phenomena should obey one or the other law of conservation of physical laws. Based on that law of conservation of physical laws only, we are going to find a relation, mathematical relation between the physical quantities present in that particular phenomena. Okay. Okay, so next we have a small discussion here. Now, conservation laws have a deep connection with the symmetries of nature. Okay, so the conservation laws and the nature, they are interconnected. How they are interconnected? There are symmetries. That means what? Symmetry with respect to time is the law of conservation of energy. What is meant by symmetry with respect to time? See, you have done certain experiments here. Okay, you have done some experiments in a laboratory. So let me assume that okay, so we have done this particular experiment in the month of May. Okay, in the month of May, we have done certain experiment in the month of May in a physics laboratory by using the same object, and all these external conditions are same. See, if I repeat the same experiment in December, now time changes. Okay, so first we have done the experiment in May. Now we are doing the experiment in December. The same experiment with the same person, with the same object. The result will remain same or change. Definitely, the result will remain same. Okay, so for an example, are you getting me? Okay, so you can give a large number of examples here. I have done certain chemical reaction in one laboratory in one season, and if you repeat the same chemical reaction in some other time, the result will remain same. Okay, it doesn't changes. Are you getting me? Okay, for an example, the law of gravitation. Okay, you have verified the Newton's force between the two objects. Okay, you are getting certain amount of F here. What is F? The formula for F? F is equal to G into M1 into M2 divided by R square. Okay, you have calculated the gravitational force in case of in the month of May, and you are repeating the same experiment in July or in December. Are you getting the same amount of force or different amount of force? Definitely you are getting the same amount of force. That means what? The physical laws, they doesn't depend on time. Okay, that doesn't depend on time. The best example is law of conservation of energy. The conservation of energy, okay, so it is always conserved. The energy is always conserved. It doesn't depend on the time. Okay, you take any time. Okay, so the total energy, it remains the same. Similarly, with respect to law of conservation of momentum, symmetry with respect to direction. What is with symmetry? In the last case, we have studied that if I change the direction, okay, if she is rotating in a clockwise direction, if I take a different direction, let me take, if she is rotating in an anti-clockwise direction, I am changing the direction. The law of conservation of momentum remains the same or changes? Definitely it remains the same. Whether you move in a clockwise direction or you move in an anti-clockwise direction, the conservation momentum remains same only. Symmetry with respect to same, the law of conservation of momentum. Okay, symmetry with respect to space. Space means what? I have taken some other position here. Okay, so law of conservation, the total momentum remains the same. Okay, you launch the rocket in Russia, or you launch the rocket in America, or you launch the rocket in India. It has to obey the law of conservation of momentum only. The basic principle remains same. The exhaust gases, they pushes the earth, and the same momentum is transferred to the rocket. Now this principle remains same in, if you take any space on the earth, now based on that principle only, okay, the rocket is going to move and it is conserved. Therefore, the law of conservation of momentum is an best example for symmetry with respect to space. Okay. Okay, now move on to the last discussion here. Last discussion of this particular topic: physics, technology, and society. So, I studied physics. Society means what we are living. Okay, so the people is surrounded. That is nothing but our society. And technology. What is technology? Technology is the practical application of physics in society. Okay, you know that technology. So finally, the human being, what we do is very simple. We first study the science. Okay, we make the laws. We systematically study the science, and finally we are using this science for our individual development, for our work, for our society. Okay, so work, what we are doing is make simpler by using the technology. So technology is the practical application of physics. What is meant by practical application of physics? The fan. The fan. What is fan? Fan is nothing but a technology. Okay, so what is the physics behind it? Very simple. Why it is moving, why it is rotating, that is nothing but the torque. And where this torque comes from? The torque comes from when you pass the current in a coil. Okay, it is a magnetic field, it experiences a torque. Now that is the principle of the physics. So by studying the physics, you have developed fan, and fan is the technology. Are you getting me? The mixer, the car, whatever may be, they are using for the modern society. They are the technologies. The mobile phone is a technology. How are you developing the technology? By using the science. Okay, you study the physics, you study the laws, and finally, by using that laws, you make a practical application to design certain instruments, and that particular arrangement, that particular instruments are called technology. And in some cases, okay, so the physics helps the technology, but they are interconnected. Okay, physics helps the technology, and sometimes technology helps the physics. Now, for an example, see, by using the physics, okay, we have developed an mobile phones. Now, physics helps the technology. Now, next is, see, now in particular this arrangement. Okay, so during our online classes, see, you are okay watching my online classes here. I'm explaining you physics by using the help of technology. I have taken the help of mobile phones to explain the physics to you. Okay, so physics has developed a mobile phone, and mobile phone is okay. I am using the mobile phone to explain the physics to you. So technology helps me to give a science in a bigger manner. Okay, so wave nature of electron. So the Louis Victor de Broglie, the scientist by the name called Louis Victor de Broglie, had made a particular observations and has given a mathematical model which shows that electrons are behaving like an wave. J.J. Thomson and J.P. Thomson, their experiments, their discoveries, okay, of this father and son, J.J. and J.P. Thomson, they say that electrons, okay, they discover the electrons, and electrons are particles. They have given the mass of the electron 9.1 into 10 to the minus 31 kg. They have given the charge by using the Millikan's oil drop experiment method, that is 1.6 into 10 to the minus 19 coulomb. But Louis Victor de Broglie shows that electrons also behave like an wave. Now that is a particular physics here. Wave nature of electron. The scientist developed a microscope by using an electron, and that microscope is called electron microscope. So electron microscope is the application of physics. What is physics here? The wave nature of electron is the physics. And what is the technology application of physics here? That is the electron microscope. Okay. So physics helps the technology. Now next what happens? Now this journey continues. Finally technology, the electron microscope, by using the electron microscope, we start, okay, so seeing an object having the resolving power greater than 10 raised to 5 times that of the optical microscope. Now the electron microscope has an highest resolution, highest magnification. So by using the electron microscope, we start studying about the cells. Okay, so you can see here in life science books, they are giving some picture about some mitochondria, some like this nucleus. Okay, they are giving the image by using the electron microscope. So technology helps the science now. Okay, so if you want to see a smaller objects lesser than 10 raised to minus 6 meters, then you have to use the electron microscope. The science is developing, the nanoscience, the nanotechnology. Okay, then in physics you have a new emerging branch here, femto technology, nanotechnology. Now that all leads to, they all start from the electron microscope. They start measuring that quantities of the order of 10 raised to minus 9 meters by using the technology. Therefore, physics helps the technology, and sometimes technology helps the physics here. And finally, who is benefited? The society is benefited. Okay, so in society, see, we have the modernized society now. You can see here, okay, in the olden days, we don't have the proper communications here. Now we have the proper communications. So the mobile phones, okay, we are using for the communication purpose. So finally, who is the helpful? Definitely, the society is the helpful. Therefore, physics, technology, and who is the beneficiary here? Society, okay, is the beneficiary. Okay, so how this technology and physics are related? I can give a large examples here. You can just go through this certain principle. Steam engine. Okay, so the railway engines. So how these railway engines are been made? So by using the law of thermodynamics. Okay, when we understand the law of thermodynamics, which says that the some amount of heat energy can be converted into work, and that work is used for the rotation of the wheel, that leads to an discovery of steam engines. Nuclear reactor, it work on the principle of controlled nuclear fusion, radios and television. Okay, so electromagnetic waves. Henry Schwartz has discovered the electromagnetic waves. Then they studied how this they are generated, propagated. Okay, so now that is a scientific principles here. So by using that electromagnetic waves during all these propagations, you are using the TVs and radios. Okay, so which use the electromagnetic waves. Computers, when we have that principle of digital logic, because the machine understand only the machine language, one and zeros. And how this one and zero, the digital signals are created from the analog signals. That's the digital logic. Okay, so when we have the theory on the digital logic, finally we have discovered the computers. Lasers, light amplification by stimulated emission of radiation. Okay, so Einstein, by using his Einstein coefficients and everything, okay, so he had made the amplification of a light by stimulated emission of radiation that leads to a discovery of laser, superconductivity, production of ultra high magnetic field. Okay, we can see the CT scans and all. Okay, so they are using the superconductivity. Rocket propulsion, it work on the Newton's third law of motion. Electric generators, Faraday's law of electromagnetic induction, rate of change of magnetic flux induces an EMF in the coil. Now that is a law. Based on that law, we have developed the electric generators. Hydroelectric power, the conversion of gravitational potential energy into an electrical energy. The falling of the water, it carries the gravitational energy, and that energy has been converted to electrical energy. Aeroplane, work on the Bernoulli's principle. Okay. Sonar, the reflection of ultrasonic waves. Optical fibers. Okay, again we are in a wireless communication. Again we are going for the wire communications. Okay, so BSNLs and others. Okay, again they are using the wires for the Wi-Fi connections and all. So the wires are nothing but they are optical fibers, because the information, the data are carried by the light by using the principle of total internal reflection. Electron microscope, the wave nature of electron. The photoelectric effect, photocells. The magnetic confinement of plasma, that is fusion test reactions. The detection of radio waves, the giant radio telescope. Okay, so now these are the relation between technology and physics. And finally, okay, so in physics we are ending this topic like this. So we have the major contributions for the exam point of view. Okay, you have to remember all these things here. Who has discovered by whom? Archimedes, principle of buoyancy, Galileo law of inertia. Okay, J.C. Bose, ultra short radio waves. X-rays are discovered by Rontgen. Electrons are discovered by J.J. Thomson. Okay, so explanation of photoelectric effect and theory, it is given by Albert Einstein. Okay, you have to discuss and each. Okay, you have to remember each and everything. So the major contributions given by the physicist during the okay, so in physics here. So now this is about the physics, the first topic of physical world. Now it is a small introductory topic. So thank you for your kind attention.